thanks everybody for joining us. We're going to do something a little unique that we haven't done at OCP in the past. I'm Rob Coyle. I'm here at the OCP Foundation. I'm a director of technical programs. I also have the pleasure of hosting the Open Compute Project podcast. And if you scan that QR code, this is not the first episode. There's many other episodes with member companies and projects and programs going on in OCP. So I encourage you to, what do the kids say? Click subscribe, hit the bell. Those are the things you need to do. I'm super honored to be here today with Bill Carter. Bill Carter is a former CTO, OCP. He's a fellow Emeritus and recent retiree. Bill, thanks for joining me.
Well, thanks for inviting me. Correct. Congratulations on the podcast.
Thank you.
I saw you doing it at a global summit and thought, wow, we should do one of these and kind of, for mainly to document some of the history, on how we got started and what are some of the early challenges that we saw and kind of share that with the community because it's really grown tremendously over the last 14 years. And many of the things that we worked on 14 years ago with networking and rack scale technology is, very evident today here in the show. And we're witnessing the third and fourth generation or evolution of some of that early work. So
yeah, thrilled to dive into it. So you guys kind of know the flow. We're going to be here for a while. We're going to kind of go back to those early days, the start of OCP. It wasn't always as smooth and as big and as great as it is here today at the show. There's been some bumps along the way. So we'll get into those, what we learned and how we've grown from it, kind of where we hit traction with OCP in the market and how the show has grown, and then kind of touch on where we're headed in the future. So stick around with us. We'll get into this. And then if you have to step away, this will also be recorded and posted to the website after the show. So don't miss that. So going back to the beginning, first, let's start with OCP first and then how you got involved. But 14 years ago, what happened? What was the impetus for OCP?
yeah, good question. And this was kind of as I recall it at that point as an outsider. But Facebook was an application, a small startup company. They had not gone through an IPO yet.
Wow.
And they had some, personnel running that were part of that startup and some really innovative thinking. And I like to kind of describe that as kind of that founder's mentality where we're going to do something very different.
Mm.
And one of those things was the design of a data center, and the other was the design of their IT equipment, and the notion of a vanity-free equipment. Obviously for cost savings, but also to be able to scale that. And so they had these design ideas, and they were putting those into small production, and eventually that would scale. I think in order to get some credit with the investor community, they needed to demonstrate that they were more than just an application, that they had some serious engineering behind it, and so they created the Open Compute Foundation. They worked with another company, Rackspace,
Mm-hmm.
and then got Intel involved as their silicon provider, and there was a couple other companies that were also invited to participate. I think Goldman Sachs was another one of the companies out of the enterprise space. So we got together and created this open hardware, collaboration.
Right.
And it was very small. It was, I think the very first meeting was in a colo data center in San Jose area.
Wow.
And they just walled off or curtained off a little area in the data center, and we had about 100 people show up.
Wow.
For the first get together, and kind of grew from there.
So when they went in the challenges of being more than just an app, or was it that they went to the market and what they wanted wasn't available? Why go along? Why set out on at that time, a radically different path than what the market wanted?
Yeah. So if you looked at servers, then traditional 1U, 2U enterprise servers, you had a lot of labels on it. You had a top cover, a bottom cover, a nice plastic
It
plate
would look
on it.
nice in an
They
office. It was
looked
pretty.
nice. They had power buttons on the front. I think they had reset buttons and then lots of connectors and things. And if you looked at that and said, gosh, if I broke out the bill of material, I'm paying for a lot of extra parts that I don't need when I'm trying to deploy hundreds of these. And from a reliability perspective, you don't want somebody to inadvertently, hit the power button in the front and turn something off or hit a reset. So it made sense to just remove that.
Hmm.
So they termed the word vanity free, and some of the early specs were, vanity free designs. And if you go back and kind of go back in history, this is Facebook's approach, but it emulated what Google was doing a year or two earlier, where they had taken just a motherboard and put it in a tray,
Right.
along with a power supply that sat next to it, and then shoved that tray into a rack. So that was the early premise of vanity-free designs, designed, deployed specifically for large-scale build-out, purpose-built machines in a data center.
Makes a lot of sense. I feel, and we'll get to this in the future, but it feels to me like we're on a little bit of a repeat of that cycle of coming from, cloud at scale into AI and the demands that it needs. The market doesn't currently meet the demands. And so we have to reiterate and reinvent ourselves again.
Yeah, I think we've been on that journey the whole time. It started
Okay.
out as, how do you, I mean, you go way back to, to the early 2000s, and, we were deploying a rack that had 3,500 watts in a, 2,500, 3,500 watts in an enterprise data center. There was no air containment. There was no nothing. It was
Right.
just a big old rack rolled into a space, and you got more than about 3 or 4,000 watts, and you had a cooling problem. You had
Right.
a hotspot in the data center.
Yeah.
Well, all of a sudden now we're going to build our first, data center. We're going to put, 20 servers in a 42U rack. And that was the scale problem that they were looking at. And then expand that, I'm going to put 10 of those in a row.
Right.
Now I got a bigger problem. And so that was part of that evolution of scale out. So we talked about, hundreds of servers being deployed, maybe thousands of servers being deployed into a data center, which at the time was, really a large room, raised floor,
Sure.
couple thousand square feet. We never, I don't think any of us ever conceived having 100,000
Right.
servers. This gets back into some of those early days that, in 2011, 2012, Facebook was building a data center in Prineville,
Mhm.
and they said, we need to do it differently. And so they designed the Open Rack as their vehicle to deploy hundreds and thousands of servers.
And
And so
is
that
that when
was
you
a
got involved?
different, yeah. So I got involved in 2012, right after the foundation was kicked off.
Okay. So while they're in what design phase of Prineville?
The Prineville data center was being built, and they had the concept of Open Rack. So they're kind of coming from this vanity-free tray, much like Google had, to a rack scale type of product with Open Rack. And Open Rack looked very different back then.
Did it?
Yeah, very different than what it does today.
Yeah, well, I'm certain it's not. There's been lots of iterations. I mean, we're in version 3, but there's
Yeah.
been a lot of changes even from the original to 2.
Yeah. So if you go back to the original design, it was actually, there was 3 bus bars on the back, not one, and there was 3 zones. So you had the top third of the rack, middle third, and bottom third. And the idea was that rather than bring in 110-volt power, to each server, which was historically how it was done,
Sure.
they were going to bring in 3-phase power to the rack and then put 1 phase in each of those 3 zones.
Oh, okay.
So that was a way to achieve phase balance. Now, we achieve it through a lot of means today through our rectification, the
Mhm.
power supply. But they were simply using physical deployment to create the phase balance. on their utility power.
Probably a
And
little.
again, back to a monolithic application, the servers in the top third, the middle third, and the bottom third were all the same server. So you had that equal balance, and their load distribution, load balancer distributed the work evenly across those three zones. And so you achieved the phase balance through that balance
Right.
for the server, the workload, as well as just the physical count in those different zones. The other thing that they had done is that the servers were hot plugged from the front. Again, that notion of vanity free, we don't need extra power cords. We'll just
Right.
put a couple of bus bars on the back. In this case, put 3 bus bars, left, middle, and third, and the sleds would plug directly into those bus bars. So that was the early Open Rack. I think it was called version 0.5 at the time.
Wow. Probably a little easier to manage that at scales of tens or hundreds of servers. Imagine do that load balancing today in a non-homogeneous deployment. Would be difficult.
On paper, I think it was a good idea.
Mm,
It turns out that as you start to look at different workloads, then it gets to be a problem, right?
yeah.
You don't have that load balancing across the phases. And the other thing is that, again, as you look at scale, we're at the time that first version of OpenRack had a lot of copper in it
Yeah.
because you're replicating all of those bus bars. Um, and, going from a 3,500 watt rack to a 15 kilowatt rack, I thought maybe we needed to have a lot more, power distribution and bus bars, and it provided some resiliency as well. But the other idea was, or the initial idea is we needed the bus bars. I think we quickly realized, or they quickly realized, and the industry, encouraged them to get rid of those extra bus bars. So, quickly after that, the Open Rack version 1 was changed over, and a single bus bar
Oh, okay.
was implemented in the back. And some of that change was actually driven by early work and early collaboration that we had with the China version of OCP. So at the time, you had a work going on in China between Baidu, Alibaba, and Tencent, and they were emulating what the American hyperscalers were doing. They created a similar organization. It's now called ODCC,
Mhm.
and we actually met the Facebook engineering team, now the Meta team, had met with the China engineers,
Huh.
and we sat together for days at a time, trying to look at ways we could consolidate that design.
Wow, it's
And
fascinating.
so the early design was never consolidated, but the notion of having, a standard rack unit moving to the full 21 inches and getting rid of that wasted space on the sides,
Yeah.
that was agreed upon.
Huh.
And then really migrating to a single bus bar was some of that kind of the early collaboration. And so, a couple years later, as the ODCC group rolled out their racks in China, and Facebook or Meta rolled out their version 2 of the rack, you saw those changes and the single
Interesting.
bus bar.
I never knew the background. I mean, I'm very familiar with the collaboration that happens within OCP, but and we do have this with our alliance organizations of the collaboration, other organizations like that. I mean, it's a really early story of us doing it. We've continued that on for a long time, but yeah, fascinating. So the narrow in on your role, it's 2012. You're with Intel, and what are you doing at that time at OCP you're a member volunteer at that point?
Yeah, so Intel was one of the founding companies for open compute, and Intel had started the data center group and had just a small team of us that were part of this new group inside Intel, and so we were, I'll say, kind of a technical advisor, to this foundation that was being created. So my role was to be the liaison between Intel's engineering teams and this Open Compute Foundation. And so the board of directors at the time had when they formed the OCP and written the original bylaws, they had identified a dozen or so projects that they wanted to start with. The rack being one, IT equipment or server project, the networking project
Hmm.
are some examples. There was actually a validation project at the time. And so, I was a systems engineer, platform engineer at the time. And so I could cover some of those technologies, certainly had exposure to mechanicals, power delivery, server design. I was not involved in networking myself. And so I reached out internally to Intel and made connections with people then that I could plug into these organizations. And by the way, that was actually a really good model to follow, and a model that I recommended for the years to come was, establish for companies that were starting to look at OCP and how do I work with them, have a point of contact in the company that could help their company plug in. And so, although I attended all the calls and the meetings, for OCP, when it got outside of my, level of expertise, I could then call upon fellow engineers and plug them into those projects.
Yeah, so then you became the liaison on behalf of Intel so that you could reach into the resources when necessary, and that way you don't have
Right.
10 people at the time, which would have been a big investment into something
Yeah,
so new
yeah.
all at
And
once.
so from there, I got involved and was plugging in and being the liaison. The foundation and the board of directors had established a technical steering committee. It was called the incubation committee. They called that because the time they felt that you needed a core group of industry influencers to incubate new ideas and incubate the projects. And so it was called the incubation committee. They had chosen from their companies a core group to sit on that. And then after a year or two, they actually held elections. And so that first round of elections, I was elected onto the incubation committee
Oh,
and
okay.
served with it along with counterparts from, Meta
So
and other
your
companies.
first role besides a volunteer member is you went from member straight to incubation committee.
Yeah, I probably got involved in the server project a
Oh,
little bit, and then that quickly evolved into that elected position on the incubation committee. And there was a lot of work that we had to do in those early days, just laying the groundwork for, how do you license a contribution? How do you onboard people? What was the scope of these projects? Again, there was nothing written down. We
right.
had no guidance, and so there's, 8 of us or 9 of us on this incubation committee, and we're trying to figure out how do you work in a collaborative environment. There wasn't a lot of precedence in the industry on how you collaborate on hardware,
Right.
and so we were dealing with, licensing issues. How do you meet? Who do you talk to internally? How do you get around, confidentiality agreements, and trying to figure out how we work together, even though we're covered by, various confidentiality agreements, with sometimes with people in the room and sometimes with people that were, not participating in a project. So these are the things that we struggled with. We put, processes in place. Many of the processes and legal agreements that we have today, the formation of just the formation of the projects and the structure of sub projects, and then later on work streams. We were kind of spearheading some of that structure. Made a lot of progress in 2 years, and it was time for a reelection. The board of directors said, "You guys are doing pretty good as is. Why don't we just leave you in place for another 2 years?"
Oh,
And
okay.
so, anyway, I got stuck in that role for 4 years,
Okay, great.
but worked with and I think it was looking back, it was really fun from the challenges that we had to work, but also the friendships that we built. And personally, I was at Intel, and our fierce competitor was AMD. And there, my peer was Bob O'Gray at AMD. I think he just retired here about 6 months ago. Um, but Bob, smart guy, intelligent, really fun to work with. Um, and so it was really an enjoyment to work with a guy that you would compete with in the,
Right.
in your kind of professional role, but here in this collaboration role, we were working together to figure out how we could work together, and that was really fun. Um, Similarly, the guy from Rackspace that was assigned to the incubation committee was Aaron Sullivan,
Mhm.
and Aaron later on went to Meta, and he's done a couple of keynotes over the years, and probably a lot of people will recognize Aaron's name. And again, same thing. He was a platform engineer, systems engineer, working on uh, IBM Power-based products. And so here you had, three engineers working together to solve, to try to create, first off, create really early specs
Yeah.
around, server technology, but also try to figure out how we work together, process wise. And here you had the IBM Power, AMD, and Intel all represented.
That's incredible. I mean, you've said a lot of things that I've experienced even in my participation in OCP of like, without the collaborative environment, those are minds, that's resources and later friends that you wouldn't have had access to without something
Exactly.
like
Yeah.
this.
And to that point, I'm still friends on Facebook with those guys. So
That's great.
yeah. Yeah.
So, we're kind of coming out of the early days, OCP starting to gain traction. What is there any standout project in the early days that really said, signaled to you, we're onto something. This is going to grow. You have OpenRack 3, but anything or OpenRack 1, anything
Yeah,
else comes out?
so early on, one of the projects that gained a tremendous amount of traction was our network projects. And if rewind back 15 years, a network switch was a closed device. You had the hardware and the software was a bundled product. It probably said Cisco on the front of it. Um, and and it was expensive, you spending what, 25,000 for a top of rack switch.
Wow.
And if you took it apart and look at the bill of materials, there's a few $1,000s worth of parts in it, but yet it's, you know, quite expensive, right?
Right.
Business margin. And so the industry recognized that and recognized the opportunity to disaggregate the switch, separate the hardware from the software. And so there was opportunities at that time with the Linux Foundation and the work that they were doing to create a network operating system based on Linux.
Yep.
And so it was just natural for us to create a white box top of rack switch.
Yeah.
And so we had companies, Cumulus Networks comes to mind, that had taken the network OS built on Linux and then was supporting um, their own version
Hmm.
of it, and it was kind of open source, but it provided, or they bundled Cumulus, support with it. So it gave customers a path to have a supported product. We had companies like EdgeCore that could build a white box
Right.
switch, and they supported the hardware. And so, and lots of other companies, just those are just two examples.
Sure.
Um, but it was a real opportunity to go grab a product somewhat off the shelf, had some support. It gave software engineers an opportunity to customize and tune it for their environment, their data center. And so tremendous amount of interest in doing that. And, like I said, our very first meetup was at a Facebook leased a data center, and maybe 100 people show up for it. I think within a few years, the mailing list for the network project hit 600 people.
Wow.
And and probably at the time, I want to say we probably had maybe a little over 1,000 on all of our mail lists, and networking alone was 600 of it.
600.
And so we really had to say, how do we address this pent up need for people to work together? And so we started having workshops, specifically, workshops for networking alone. And again, back to, Cumulus Networks, they were one of the folks that allowed us to come in and hold workshops. They certainly talked about what they were doing, but
Sure.
their competitors came in and presented. We had hardware companies that would come in and present. Um, and then the hyperscalers, particularly Facebook, was highly involved in creating standards for these white box products.
Yeah.
And so at that point, we had a dozen or so white box product specs, and then companies could build their operating system on top. You could have the hyperscalers build their own software network stack on top of that, or third parties that could integrate.
I mean, that continues today. I mean, there's obviously lots of networking companies involved and that white box effort. I mean, we see it here in Europe. I mean, enterprise open networking is like top thing here in EMEA. I mean, it's incredibly popular. Um,
Yeah, and we saw that because we saw the explosion of hyperscalers, doing looking at that as an opportunity, and and then obviously enterprise wanted to do the same thing, and they were able to embrace wide area network technology and integrate that into their solution. They were able to then look at private cloud, public cloud offerings, which as I understand, a lot of the is based on network security and the network connectivity to your public cloud,
hmm.
and so they could build that with that open disaggregated switch. The other thing that happened that was really interesting is um, the merchant silicon market. It opened the door for new merchant silicon, and so you had several different merchant silicon providers of switchgear now could build these white box
Oh
switches,
yeah.
and I think Big Switch Networks is one of the names that come. There was another company that a couple of new silicon companies that kind of emerged out of that and built some white box switches and allowed them an opportunity to build to this common spec,
Right.
and create somewhat interchangeable hardware components that could drop into these applications.
Excellent. And as opposed to, previous either custom or heavy business layer on top of switches, they then had an opportunity for multiple customers because anybody who's
Yeah.
open
Yeah.
network, they could, diversify their, customer pool as
Yeah,
well.
so we saw that business, kind of really blow up. I mean, it created, new businesses were emerging, in the Bay Area, in
Yeah.
Silicon Valley. You'd start to see these companies emerge.
Fantastic. Okay, we're moving on to OCPs as they're gaining traction networking. Decathlete was a popular spec.
Decathlete,
Yeah.
yeah. So by the way, Decathlete was a real simple 1U, 2U, general purpose server, and so again, looking at what the hyperscalers were doing, we said, well, we can do the same thing for enterprise. And what enterprise wanted was a white box option, and so we said, okay, if we can create a specification that was written such that it would fill a particular usage case. In other words, it had a certain amount of storage capability, a certain amount of memory, and I think at the time it was, required 16 DIMMs, um,
Okay.
you know, and a DP solution, dual processor solution. So if you had a white box that was 2U, supported, two processors, had 16 16 DIMM slots that kind of dictated how much memory you could have. And then depends on how you populated it. You could meet different applications, tune it for different applications. You could create one common spec that could then be deployed across many different applications. And it allowed a company, an enterprise company that operated a private cloud to buy the same hardware, make a deployment time decision as to how to configure it and deploy it and then support it. So it reduced the number of SKUs that they had to have in their fleet of hardware. And the other thing we were able to achieve then is when we had this, I'll say this black box interchangeability. So you had to have a certain amount of ports on it and a certain amount of functionality and performance, and some management features. We actually defined the level of the features that for hardware management that had to be supported in the firmware. It allowed that interchangeability, and now we had several different suppliers, different ODMs and different OEMs that could sell a product that met that spec. So if you're a private cloud operator, large or small enterprise, you could buy a product that met that spec and have some level of guarantee that it was interchangeable.
Right.
At the application level, if you're doing VM hosting and you're trying to, host, 32 VMs on each machine, there was a pretty good chance that there was 3 or 4 different vendors that could provide a machine that had the level of hardware management that allow you to plug it into your data center.
Interesting.
So the other thing that was really interesting about that is that the Decathlete spec was provided by Intel,
right?
And the corresponding spec was called Roadrunner,
okay,
and came out from AMD. So again, back to that early collaboration and between our incubation committee. Guess who writes the AMD spec? It's Bob O'Grave.
Oh, funny.
Guess who writes the Decathlete spec? Yeah. So Bob and I are working together.
Yeah.
We're writing a spec which is ultimately going to compete for the same business
right
at these large enterprise customers. And yet we're trying to build something that's interchangeable.
Interesting. That's people ask often when we're having conversation about early membership or why they're involved in OCP, and the way someone put it to me was like, I want a bigger pie, not a bigger slice. And it's easier to go get that business. Grow a common spec that can be big, that Intel and AMD can both go after a bigger pool of business than go it alone.
And at the time, Intel was, we didn't sell systems that were sold through, ODMs and OEMs that would base it off of a reference design. And the same with AMD. They would do Bob would do a reference design, hand it out to his supply base, and they would resell it. So again, it allowed dozens of companies to sell a spec or sell a product that they met off a common spec. So and this common spec ended up being, I think in the end there was probably 1 million systems that were sold.
Oh my gosh!
And so we didn't realize that till 2 or 3 years later. We contacted a market research company, and they went back and looked at, contacted the suppliers, said, by the way, how many products did you sell? What was your revenue based on these OCP specifications? And we were amazed at what the numbers were coming back. This was not small numbers. I think at the time it was IHS Market.
Yeah.
And they did some of the early market research for or on behalf of OCP, and it turned out these were huge numbers.
A little bigger than
a little bigger than what we thought.
Yeah, that's awesome. So then you have these 2 competing products in the market. How do you signal to the market that these are OCP spec? Is this where like OCP Inspired comes into play?
It did, yeah. And so actually, great question, because we wanted to differentiate between a product. So at the time we're thinking, we're an open hardware company, and open implied, if you kind of looked at the Linux Foundation model, open implied, everything, you had the source code, right?
Yeah.
So from a hardware perspective, open implied, you had the design files, the schematics, the Gerbers,
You could
you know,
take it and go
the
build it
bill of
yourself.
material,
Yeah.
the AML, right? You had all of that information.
Right.
And so there was some companies that are willing to share all of that. And then there was other companies that would build to that spec, but didn't want to share their bill of materials or didn't want to share their design files.
Sure.
So we created those two brands. OCP recognized as
Yep.
being the product that had all those design files available and you could go download it.
Yep.
And then OCP Inspired for products that were built to the same standard but didn't have that documentation,
Right.
behind it. And at the time, we felt it was important to have that all those design files for business continuity
Sure.
to assure that if something happened to that supply chain, that they could go grab the design files and take them somewhere and have them built. And the reality, as a design manager, I really understood this pretty well. But the reality is, it's really expensive to put something like that in production.
Oh,
Having a schematic is, as a design engineer, you can get to a schematic level product pretty quickly. And most of the schematics came from the silicon provider anyway.
right.
So you had a reference design to work for. Once you had that reference design, you still had to build the product. You had to test it. You had to do all your design verification, make sure all your low level, timing was correct. Do your full design analysis, do your full level of validation with peripherals. You had to build test fixtures. You had to do tooling. Getting the design was cheap compared to putting it in manufacturing.
Right.
So we really said, it's not important to have all those design files as long as we have these common specifications. And so that was our focus. And that was the evolution of OCP Inspired and OCP Accepted.
Well, it continues today. I mean, if you look at the OCP marketplace, the vast majority of things there are OCP inspired.
Yeah.
And if you're a new company and you want access to IP that creates commonality, if you really want to go through the tooling, go through the investment there, you're going to do it because you want after that market.
Right.
Someone handing that to you is probably not the decision whether to be involved or not.
Right. There was a lot of reluctance in the early days for companies to participate and contribute to OCP. There's people that are here at the show that I met with in Taiwan, back in 10 years ago.
Mm-hmm.
And the question would come up, I don't want my competition from stealing my design.
Of course.
I spent all this time to come up with my schematics. This is my intellectual property. And we had tested that internally and said with other adopters and other companies in the supply chain and said, are you copying these designs? Are you using the schematics and lifting it? And, in all cases, we were finding that people were not taking a schematic and reusing it. They may
Really?
reference a schematic, may look at it,
Right.
but they just were not copying a design exactly.
Huh.
And so my comeback when we'd have these conversations is I'd say, if you think the design itself is really valuable, put it on eBay and see how much you can sell it for.
Right.
The reality is that the design itself, it was the manufacturing and all the support behind it.
Yeah.
That was their service that they were providing to their customer. And so after a few years of those discussions, people really realized that, yeah, they're right. People are not stealing my design. Now, I will say that on the networking space, having a bill of materials that you could, upload it or download that was available, actually benefited the entire industry.
How so?
And I think the folks at EdgeCore actually figured this out pretty quickly. So if I'm building a network switch and I have redundant power supplies, I can go source my own power supply, or I can go look at what everybody else is using. And if I go look at what everybody else is using, I use the same power supply.
Sure.
And so I'll use the exact same part number, right? And so now I drive the volume up on that part number with the supplier. It ultimately drives the cost down. It drives or it improves availability for not just them, but for the original um, person that used it, but
Right.
for everybody else that uses it. And so there was a lot of examples where, connectors and power supplies and little mechanical parts
Right.
would get reused across the OEM or the OCP community, but they weren't quote stealing the design. They weren't using it per se. It was just let's just be smart about how we, the supply chain and how we purchase.
Yeah, there was a early conversation. I remember I watched a very early presentation from over 10 years ago about server design, and it was this, um, gross part number. That was these moats that people tried to build, but they created no value. If
Right.
you had
Yeah.
one server and it had, you had all these different part numbers that you'd use for different power supplies. I think somebody did an analysis of how many power supplies were available to servers at the time, and it was far more than even the available server SKUs that were
Yeah.
available. There
Yeah.
were thousands upon thousands of. Why do we need so many power supplies that do the same exact job but aren't interchangeable?
Yeah.
So I think
Yeah.
that's another kind of like the networking uncovering of like there's a lot of optimization here in reducing this part number list.
Well, and again, back looking at the top of rack switches, you know, you needed an adapter to take a 19-inch switch and put it in a 21-inch open rack,
Right.
and so there was no reason for a dozen companies to tool up this metal tray. If we could just
Right.
go buy the same part number from someone, it made sense for everybody.
Yeah.
So there was a lot of I'll just say sharing that was going on that benefited the original contributor as much as the adopter.
Yeah, and it being unique to the OEM or whomever it was no competitive advantage. It didn't serve the customer. It didn't. It was just an
Yeah.
inefficiency.
Yeah. So that concept of, sharing an idea, has really evolved. And so, if you look around the show floor today, there's a lot of dripless connectors. I'm just going to use that as an
Sure.
example.
Timely.
But, 20 years ago, dripless connectors, so dripless connectors not new. It's
Right.
been around
Oh
forever,
yeah.
right? Um, the fact that we finally got everybody to talk and get together and decide on a common design and then share that design. Now we have commonality
Oh yeah.
across this dripless connector, and that has enabled IT equipment to plug in, hoses to work and enter, all this interoperability just falls out of that.
Yeah.
Um,
Yeah,
and
that's a great example of one that basic OCP principles that it's evolved and now have come to liquid. I mean, the back of rack connections that are dripless and the universal quick disconnect. I mean, that is an incredibly popular project today.
yeah, yeah.
So that's a great example. Any bad examples of things that were well designed that just didn't work out well?
Yeah, yeah, good question. So we've seen a lot of what I'll say are good designs in my mind, um, and I I don't want to pick on anyone to because they're all really good designs, but um, we've seen some integrated rack solutions that have been proposed and contributed to OCP over the years.
Mhm.
That if you look at it, they're really good designs. They're built off a 19-inch rack. Had a lot of free features, um, but it was a design that was done in a vacuum by a single company,
Mhm.
and then you get the entire design done and you hand it over and say, "Here, go use my design."
Right.
Right? And and it worked for the original designer. It worked perfectly for them. Worked in their data center. Had they made a little minor change, and it could be as simple as adding the support for a management feature in their firmware stack
Huh.
that allowed them to remotely turn it on or off, or remotely do some telemetry. Could be as simple as that.
Yeah.
Had they allowed that to happen, then it would be useful for a second consumer or a third consumer.
Sure.
Um, And so, there's been products that have been, contributed to OCP that did not take off
Right.
and were not successful. And I look at those because we didn't have enough collaboration up front. So, fast forward, what did we do? Well, we said, let's encourage collaboration from lots of companies up front and get them involved in the spec.
Yeah.
And what did we learn? The more people we have involved up front, the faster the adoption is. You go back and look at the OCP MES card. Facebook released a spec and it was actually 0.5, the original MES card.
Yep.
Never even made it to 1, right? Pretty good adoption. Well, when you're Meta and you're buying a million of these cards, right? People are going to line up and build the card, right?
Yes.
But it worked for Meta. It didn't work in other applications. So we didn't see a lot of ODMs pick up and design a system using that, I'll say, proprietary Meta
Right.
MES card. So, now they want to rev it to the Rev 2. So OCP, we get involved and say, gosh, if you can get with these suppliers or these ODMs or these other potential consumers, and if you can modify the spec a little bit,
Right.
put some sideband signaling in, maybe change the panel to allow different connector configurations, maybe allow the PCB to be slightly longer or even, wider.
Doesn't
Then
mean you have to use that
different
one, but leave space for it for someone else.
either leave space or simply just grow it by, let's say, 1/4 inch,
Yeah,
right?
yeah.
Or allow the panel to be slightly different, right? If you don't constrain it as much and you allow these provisions for sideband signaling, right? I think that was one of the big changes with the MES card 2.0 was the addition of sideband signaling, as well as just overall throughput, bandwidth. All of a sudden now you had a product that was applicable to that particular customer. In this case, Meta was writing the spec, but now you had ODMs that could then turn around and build that into their product. And so when the MES 2.0 card came out, now we had OEM and ODM platforms that were adopting it.
Excellent.
And that's when the market just blew apart with that. And everybody, and so you had these, think back prior to the MES card,
Yeah.
you had lots of embedded cards that were being designed by each of the ODMs or OEMs, right, as their proprietary design. Once we got to MES 2, we started to see people just align with these cards.
Yeah, and other variations come in, and
and now all of a sudden we
options are
have, a couple years go by, we have the Rev 3 or Release 3 of the mezzanine card spec.
Yep.
And, and it's used everywhere.
Oh yeah.
But
It's
again,
very
it goes back to, what was different. We got more people involved earlier.
Yep.
We gave them an opportunity to voice their concerns, voice their suggestions, did it in a way that, in a framework that said, hey, I'm going to throw out my ideas, and those ideas may get picked up or may not.
Right.
And, don't share your ideas if you want to keep it proprietary. Share what you want to share and make public, and hopefully they get built into the next spec.
Yeah, absolutely. I mean, anybody listening, take it from Bill, who's lived it. We have conversations all the time. You get a couple voices in the room early.
Yeah.
If just because you have IP that you're willing to contribute, and it goes alone, doesn't mean it's really going to get adopted. So collaborate, have those conversations early.
Yeah. So, years later, we went back and asked, looked at the specs and said, what specs really made a big difference to the market, to the industry? And it was specs that had 3 or more collaborators.
Yeah. Either end users or vendors, right?
Yeah. So again, what's a good example of that?
Sure.
I'm going to ask my own question.
Please.
The DC MHS, the modular, sort of a modular system. We actually had 2 different groups of people that had come to OCP with a very similar concept of a modular solution.
Yep.
And I'll say 2 different camps, and each camp had 3 or 4 or 5 companies involved with it. And it turned out that their designs were different but similar. It was gonna fulfill, the same purpose. Uh, it would've had either one would've had the same impact, but we had 2 different designs.
Okay.
And when you have 2 different designs in the industry, I've witnessed how they compete against each other, and the industry will wait and see if there's a winner.
Sure.
And you think about, PCI bus versus the VL bus with video cards.
Yep.
This goes way back, 30 years. You think about, the different protocols for direct memory access that have been competing protocols. You think about, connectors, lightning connectors and USB connectors,
Oh, yeah.
how they would, compete with each other. It really slowed down adoption, right? And my biggest fear with modular was we had 2 camps. They would come out, and they would compete against each other. And so what we were able to do is get these 2 camps to talk to each other. And, we did it. We didn't share confidential information. We
Sure.
just said, "Hey, here's a phone number and a contact. You should have a coffee together."
Yeah.
Encourage that. And those conversations evolved into these groups saying, "Hey, there's a lot of things we could do together. Maybe not the system may look different, but the components can be the same."
Yeah.
And eventually that conversation rolled into becoming the DCMHS spec.
Which is wildly popular.
Which, yeah, it
and,
is.
And quick plug for anybody's in earshot. Over in Innovation Village, there's lots of great examples of DCMHS being used in ways that back then probably would have never fathomed. We have remote liquid cooling, hardened solutions, all sorts of wild stuff.
Yeah. And so I happened to look at one of the specs today because I thought, well, we may talk about this.
Oh, okay.
So I looked at the contributor page, and I'm looking at all the names on there. 7 companies. This was the density optimized specification for a half-width board. So it's used in these AI ML solutions,
Okay.
right? It's the GPU sled with high bandwidth memory. And there's 7 companies that contributed to authoring it, and it listed the names of the companies. And lo and behold, the names on there are names of engineers that at one time may have worked for Dell and now work for AMD, may have worked for Intel, now they work for Dell or HP. So what we're seeing is that the companies change, the names remain the same.
Sure.
And I attribute that back to the relationships that are built here, in this room, but more importantly, built in the work, the work stream and breakout sessions that are going on.
Oh, yeah.
Where you're on a weekly call, you're talking over Zoom to, somebody that happens to work for your competitor.
Right.
And pretty soon you have this conversation back and forth and you realize, hey, they're a pretty good engineer. I trust what they're saying.
Yeah.
I have a respect for them and a respect for their engineering work that they're doing. And so now you put your name on a spec with them and you do it once and you realize that was a good experience. I want to do that again.
Sure.
And so the companies change, but the names don't.
No.
And so our DCMHS specs, and there's a family of specs, you'll find that, the engineers involved in writing those, they have a long history. And
Sure.
part of that history was written by their participation in OCP.
Yeah, excellent. What a great example. There's been some, we're going to turn towards the future in a moment. Before we get there, you mentioned one other open organization. It was a good collaborative experience with the Chinese organization over OpenRack.
Yeah.
But there's been other organizations too. Any that jump out to mind, good or bad, that in the hardware space?
Yeah. So let me try to answer that a little differently. one of the things that we have done is look at the engineers that are here, look at the business leaders that are here, and say, um, we want to collaborate. We want to create an environment where we can bring birds of a feather together.
Sure.
And if we can do that, a couple of times a year around the world, that would be perfect. We don't want to ask, and it as a as a business leader, as an engineering manager, you don't want to have to send your engineers to 4 different locations to get the same information. If
Yeah.
you can bring them all under one roof and just let us work for a week or so, it's much more productive. So our focus has always been on looking at the community and where it makes sense as a community, where can we put these birds of a feather together and into work groups? So we don't view other organizations as competitors to OCP. They simply have a different group of birds. So,
Interesting.
Linux Foundation is made up of software engineers.
Sure.
Okay. So software engineers, that's great, right? They'll do their own thing, right? Hardware engineers, we want to be the place where hardware engineers come together.
Yeah, absolutely.
Mechanical engineers, thermal engineers, hardware design engineers. We want to be that forum for folks. It turns out that firmware engineers tend to have, everything, all their firmware runs on hardware. So
Right.
that's been a natural fit for a lot of the, open system firmware, embedded firmware folks
Oh yeah, absolutely.
to come here as well. So although there's other organizations that are different, we don't want to replicate what they're doing.
Sure.
We support them, and hopefully they support us, and really focus on what's best for the community, and whenever possible, even to this degree, if it meant, would we merge with another organization? Certainly would entertain it, because again, we really want to make it easy for people to work together, collaborate, and not force people to kind of choose.
Yeah, absolutely. One example that is more recent, and there's been many along the ways, is our partnership with Infrastructure Masons and the
Yeah,
Climate Accord. They were working on carbon disclosure and labeling. So were we. We had interest, and a lot of people in this community were the same birds in that community. They said,
absolutely.
"Why are we going at this either duplicating efforts or potentially creating confusing efforts?" And they're here. The sustainability track is all day today. There's a bunch of iMasons folks there, obviously a bunch of OCP folks, and they're really hitting the
And
ground together and flying together.
right, and I think you were a big proponent of bringing that together, and making sure that our cross licensed, and let's don't replicate if we have trademarks or
Yeah, yeah.
licensing or specifications, that it's all we're not duplicating efforts, we're cross licensing wherever possible. We support that effort, we give them space, we give them boosts, we do
Oh, yeah.
whatever we can to continue to nurture that. And by the way, to that end, we probably should talk about Europe,
Yeah.
and in the context of sovereignty. This week, and leading up to the summit, I have had numerous conversations with folks here saying, um, it's really important that we build work streams and build projects that are launched, that are incubated, that are staffed and ran out of the different geographies.
Sure.
And, obviously, y all countries have concern about, data sovereignty, and general, just business sovereignty in general. And when it makes sense, I would encourage new projects to be launched and ran out of Europe, ran out of specific countries.
Yeah, absolutely.
And I hope one day that we have, that we have as many projects being ran out of these geographies as we have running out of the Americas.
Yeah, that would be fantastic.
And I hope that those projects are different, right? That they're focused on local needs, and I see that happening. I see a lot of opportunity for that.
Yeah, I mean, there's lots of, I'm sure there's more, but there's obvious examples like things like heat reuse, which are incredibly applicable in Europe, are more difficult to obtain in the US. You have different regulatory requirements. We do need the local boots on the ground visibility. And I'll lead into like, how does, for those who don't know, how does OCP, like we as the foundation, we're the enabler. We don't really pick what goes. We can encourage and we can advise, but
Yeah,
really it comes from, it's grassroots. It comes from the community, right?
yeah. You said we don't pick. I want to key off of that.
Okay.
Um, one of the things that we've done, and I've been pretty proud of myself, is that I don't want to pick winners. I don't want the foundation to pick winners.
Never have.
And so going back to the DC MHS as an example, that was a case where you had two competing specs, and we did not want to have the foundation in a position where we had to pick one over the other. Um, so our first suggestion was bring them together, and hopefully they would work together.
Hmm.
And once we made those introductions, the rest just unfolded on its own.
Sure.
There will be cases where that doesn't happen, that we will have, two competing standards, two competing projects.
Sure.
Again, hopefully we'll always be able to support those and never pick a winner. Let the industry decide.
Yeah, absolutely.
Let the industry pick a winner, and there may not be. There may be cases where each of those solutions, although may be perceived as competing, may make sense for different applications, different customers,
Yeah, different market segments.
different market
Yeah.
segments. Yeah.
Yeah, that makes sense. So we don't pick. You covered that. Now where do we go? We're,
Oh,
we have a vibrant community. We're expanding our growth is 40+% year over year here in Europe. You
uh-huh.
said Europe's a massive opportunity for growth. We have obviously over the last 18 months to 2 years an influx of a lot of AI workload driven projects. What's next? What do you see for the future?
Yeah. So where do we go? So I'm going to answer that. I'm going to start 3 or 4 years ago.
Oh, okay.
So 3 or 4 years ago, we had nobody we didn't have any boots on the ground in Europe.
True.
And Steve Helvey was working over in Singapore, Hong Kong, handling Asia. And we looked at our market research data, again done by IHS Market, who at the time was managed by Cliff Grossner. Cliff now works for OCP.
Yep.
And we said, the data says that growth is going to be in Europe. Even though there was this tremendous volume of business in Asia, we said growth is going to be in Europe, and it's going to be in the next few years. So we actually had Steve relocate from,
Yep.
From Asia back to the UK. We brought Mark on board. We actually recently hired Raul and brought
Yep.
Raul on. So we put resources in place a few years ago. We've built out this community of volunteers. And so we recognize that Europe had the potential to be a growth opportunity for collaboration, and we wanted to be a part of that, and it's panned out. It's paid off, as you can
Evidently.
see here,
Yeah.
right? Um, so, we didn't walk away from Asia. And in fact, we're now got Europe off the ground, right? Things are running. We've got a lot more work to do here, a lot more
Sure.
opportunity. We're going to move in and have a similar event in Taiwan. Again, there's a lot of pent up demand there.
Yep.
A lot of great engineers in Taiwan.
yeah.
It'd be nice to get them to, work together. We're doing that. We've been in Korea. We'll do the same thing there. So we can expand our footprint. I hope that we expand the number of projects, and that collaboration really drive at the engineering level that collaboration, and that we're authoring specifications out of these geographies. So specifications are not necessarily being authored in the Americas, but they're being authored in in Asia, in Korea, in Japan,
Yeah.
in the UK, in Europe.
Yeah.
Love to see that.
We need those different perspectives for
Yeah.
sure.
I mean, especially around sustainability, heat reuse. We really don't have heat reuse opportunities in the Americas.
No. No, I mean, there's some unique applications. I think I saw, a Bitcoin mine heating a swimming pool in New York, but aside from that, it's not as widespread. So yeah,
I did the math on that to heat my pool
you?
in Phoenix, Arizona.
Yeah.
I'd have the pool would be boiling in about 2 days.
Maybe not a worthwhile effort. Well, we're about to wrap up here.
Okay.
Any final things you wanna leave us with? You're headed for retirement, which I'm sad to hear.
Yeah, I'm gonna finally talk my wife into retiring, and so now she's gonna talk me into it. So
That's good. Well, I'm so glad you're here. I watched from afar. As some people don't know, I was a part of a member company. My journey at OCP started as a member volunteer, and watched you on the keynote stage for many, many years. They ate my first OCP summit probably nearly 10 years ago, where you were CTO then. So, thank you for all that you've left for us to build on top of. Thank you for doing this interview with me, and we're able to document some of those finer details, like not just the specs. We have records of specs, but there's stories with those specs, and there's people and individuals, and there's takes on those that we don't have. So now we do.
yeah, it's really about the people.
Yeah, absolutely.
And so I think we have we have a wonderful startup community. That's really exciting.
Yeah, very.
We have a really good group of engineers that are now, that and have been working together for 14 years. They like I said, the company changes, the people don't. We have a trusted relationship with everyone, and a legal framework that we finally ironed out.
Yeah.
Over the years.
Yep.
So it's future's bright.
I agree. Thank you very much.
Thank you,
Phil.
Rob. I
Appreciate
appreciate it.
Yep.